about Stabilised Urea, and this presentation mainly arose just from interest from yourselves asking about Stabilised Urea. We have done quite a bit of field trials using Stabilised Urea since about 2012, so I'm just going to go through our results, just a brief summary of what we have found. Okay, first of all, what is Stabilised Urea? So Stabilised Urea is urea fertiliser coated with an inhibitor, NBPTPT. The inhibitor can be incorporated into the granule itself in the melt, or it can be just coated with it, and it often gives the urea like a blue or a green coloration. So what does Stabilised Urea do? Okay, so when you add urea fertiliser to soil, it's converted into ammonia, and the plant then can take up that nitrogen. This process is quite quick, so in the few days after you apply urea fertiliser, it's converted into ammonium. And in that time, you can actually lose a lot of that nitrogen from the soil up into the air as ammonia. And this is mainly dependent on the conditions. So if you're applying in warm weather, if it's very windy, a lot of sunshine, the soil temperature's warm, you can actually lose about 30% of your nitrogen in the first few days after application. So it's very dependent on the conditions. So if you apply protected urea, the inhibitor in that urea will slow the whole process down. The grass has more chance of taking up that nitrogen before the nitrogen can be lost from the soil. So nitrogen is very soluble. It can be lost through leaching, or it can be lost up into the air. So we want to try and minimise losses of nitrogen from the soil, and so your grass can get better use of it. So in terms of urea, if you apply it in very warm sunny conditions, even this is slurry as well. If you pull out slurry in warm sunny weather, you can lose up to 30% of that nitrogen up into the air. So Stabilised Urea, it does work, and it can reduce that ammonia loss by up to 70%. So it's been proven to reduce ammonia loss. Now CAN is the main fertiliser we use in Northern Ireland. CAN is ammonium and nitrate, so it's a different form of nitrogen. The problem with CAN is because of the nitrate in it, that can be washed through the soil, or it can go up into the air as nitrous oxide. So you've got two things going on here. With urea, you can lose ammonia, but with CAN, you can lose nitrous oxide. So with any form of nitrogen you're using, it is at risk of being lost. So we want to try and minimise those losses. And with CAN, if you apply CAN in wet weather, it's more prone to being lost after rainfall. So if you put on nitrogen fertiliser as CAN, it can be very quickly washed through the soil and lost if you get a lot of rainfall in the days after you've put out your fertiliser. So the conditions are very, very important in terms of nitrogen. So we have done a lot of field trials using both CAN and urea and protected urea or Stabilised Urea, where we have grown grass in plots with different fertilisers. We measure yields, grass quality, we look at ammonia loss, nitrous oxide loss. Okay, so there's a lot of data, a lot of these kind of graphs from about 2012, and there's been work also down in Wexford through Chagas. So we've been working with them a wee bit to have different field sites, different conditions. And overall, even though the inhibitors do work, they do reduce ammonia loss, and there's also inhibitors you can use with CAN fertiliser that wouldn't reduce nitrous oxide loss. Overall, there's very little difference in the yield you get at the end of it when you look at all the different cuts and for the year as a whole. Very dependent on conditions. So some years, if you get a really dry year, then your Stabilised Urea will work better because you're reducing ammonia loss. But if you have a wet summer, where there's more chance of nitrous oxide being lost. You know, there's different processes in different years depending on the weather. So overall, we've found really little difference in overall yield. So this graph is, there's CAN here, urea, protected urea is the yellow one. So sometimes it will outperform normal urea, but really there's very little difference overall between the fertiliser types in terms of yield. But then there are years where it hasn't done as well. So for example, 2017, Stabilised Urea did not do as well. And overall, we found that generally it wouldn't outperform CAN. CAN is generally your better performing fertiliser in terms of yield. But in some cases, depending on the weather, it will be better than urea. And there are legislation talking about in terms of reducing ammonia loss on farms that you would replace urea with Stabilised Urea. So if you use urea, you could replace it with a Stabilised Urea, and then you wouldn't be losing any yield. But really, overall, CAN is still sort of the better fertiliser. And the conditions for stabilised urea, it does degrade very quickly. So if you have an open bag in your yard, if you have it sitting there, the inhibitor will actually degrade. So the performance of it can actually go down over time. You need to buy it fresh every year. You need to use it quickly, because if you have it sitting in your yard, it mightn't work as well. So these are various conditions with it. And I'm going to hand over to David now. He's done some other work on stabilised urea he's going to talk about.
Well, good morning, everyone. Or good afternoon now. What I wanted to do was try and take what Suzanne has worked on and others over the years and look at it in a silage, three-cut silage system, because the practices and the technologies and the experience of making good silage are pretty well understood, but there are still some risks when we think about silage making. For instance, getting the nitrate levels down to a suitable level. As you can see here in the bottom point, the target is always trying to get those down to below 1,000. So bear that in mind, and you've heard as well there, third point that Suzanne was making was that there are certain advantages, as she has outlined, in terms of using stabilised urea in the first place. But thinking of it in a silage making context, we set up a trial here at Hillsborough, which ran for 2 years. The objective, as you can see there, was to basically measure the impact of the fertiliser nitrogen type on the seasonality and the performance, the productivity and performance of the grass over 2 years. The products that we were using, just for interest, was a 38% nitrogen, 0017 sulphur, and that was the substitute urea. And the sulphicam product was also in the trial alongside that, which was 26.6% nitrogen, 00 again with sulphur. The rates that we were applying, 120 at first cut, 100 at second cut, and 100 again at third. And like I say, we assessed productivity by yield and grass quality right throughout each of those cutting cycles. Bear in mind as well, Kat was outlining all the detail earlier, but we had the challenge of the two contrasting seasons. This trial happened over 2018 and 2019. So obviously there was a fairly significant drought in the south and the eastern part of the province anyway through 2018, and that had an impact on the results for 2018, but in a way it was good in that there was a challenge for the growing of grass and for the products, for the silage fertilisers at the same time. And then more normal conditions returned in 2019 to this side of the province. So mashing all of the results together, this is a very simplistic, it's as simple as I could get it anyway, for the results of the performance of the products side by side. You can see there, if you scan down these two columns here, the can performance alongside the stabilised urea performance in terms of yield. We were taking harvests at week 2, 3, 4, 5, 6 and 7 for each first cut, and then again we did the same again for second and for third. So you can see there that side by side we were looking at the seasonality of the production, not just the total yield performance. But at week 2 they were similar, week 3, week 4, week 5, week 6, right down to week 7 where we actually cut it for silage. You can see there on average, this is all 3 cuts averaged together, just over 5 tonnes and slightly more with the stabilised urea, but no significant difference there. So the main point so far, it was yielding as much as the can fertilised plots. We also took quality samples at each and every one of those weeks, but again the crude summary of all of that, you can see there they were dangerously close to one another, 10.99, just under 11 ME for both the can fed and the stabilised urea fed. Crude protein again very, very similar, and like I say, this is across 3 cuts over 2 years here at Hillsborough. The control over the side here was quite interesting in that you can see what you get with no fertiliser building up over the 2, 3, 4, 5, 6 and 7 weeks. So there's about 3 tonnes of grass there produced, taking nitrogen from the soil, nitrogen pool itself, without any additional fertiliser, and no slurry applied to this at all. So in other words, the yield performance and the quality performance was comparable over a 2-year study. A side shoot of that, we are talking about a silage making context here, and what we did find that there was an interaction when we looked into some of the numbers. There was an interaction with nitrate levels and the product type over the 2 years. And you can see here, apologies for lack of colour in these graphs, but on this graph here, first of all we did was we separated out the product types for all 3 cuts And you can see here, if you're familiar with nitrate levels, you're obviously trying to get those down to 1,000 or below before you cut for silage. So you can see here that both products, the CAN and the stabilised urea, were gradually falling from about 2,500 as you go through the growth period from week 2 to week 7, and surprise, surprise, they were ending up just under the 1,000 by about week 6 or week 7. So you could say, yet again, the products weren't showing up much difference. But when we teased that out a little bit further, we separated out, forget about product type now, we separated out first cut versus second versus third. And what was interesting for me anyway was that the first cut nitrate levels weren't that high to begin with, and they stayed low the whole way through, okay? And I'm not sure this type of graph has been published before. The second cut and third cut both started pretty high, as you might expect, and dropped comparably for the first 3 or 4 weeks, let's say, and then separated out. So you can see straight away that third cut, and we're trying to produce silage now right across the whole season. This was a 3-cut system. If you go to Holland, you could be talking about a 4, 5, maybe 6-cut type system. But what we're trying to get is a consistent quality and quantity across the whole silage harvesting season. So third cut, there's a bit of a problem there. With nitrates, there's some resistance to the nitrates falling, and there's a whole combination of factors at play there. There's the type of, the nature of the grass at that time of year, the season, the weather, what's going on in the soil nitrogen cycle. All of that's at play, but that's the result. Nitrates weren't coming down as low, so that was interesting. We thought we better tease that out a wee bit further. So what we looked at then was for third cut only, just taking the third cut data, we separated out the product effect again, and you can see here that both, not unlike the first graph, the CAN and the stabilised urea nitrate levels fell similarly for the first couple of weeks. But here there was something strange started to happen in that the stabilised urea graph, which is the dashed line, kept on falling. And it was the only one that actually got underneath, just about underneath the magical 1,000 figure by week 7. Now I'm not saying this is a huge issue, but there's something going on there that needs a little bit more work to unravel. I almost came across this accidentally. So there's something going on. Third cut is notoriously hard to make good fermented silage with. So maybe there's something there to suggest that the stabilised urea is better at getting the nitrate levels down to the right level. But it's a tentative conclusion at this stage. So in conclusion, the main story is that the stabilised urea and CAN plots in this trial over 2 years produce similar yields and similar quality. And you might say, well, that's not that's the main message. But we also, like you saw, looked at the seasonal profile, and that was similar as well, and the efficiency of nitrogen uptake. But there was this question mark about what was happening at third cut time of year. So overall, I would say the stabilised urea story, it's providing some degree of assurance to farmers if they were using that. We were using that in the trial right the way through the season. It provides some degree of assurance at this stage, but let's not get it out of context, and let's not get that nitrate story out of context. The principles of making good quality silage are still what they were. It's about cutting dates, and it's about wilting when there's opportunities, and all of the other features of making good silage don't change, but this is just a couple of the points that have come out of this one trial. Okay.